Okay, hello everyone. Welcome to the third annual Mars Society Design Engineering Contest. I'm Nicole Willett. I'm the Director of Education Programs for the Mars Society. And today we're going to have Dr. Robert Zubrin. I'd love to welcome him to the Zoom with all of you. And if you're watching the replay on YouTube, all the information will be linked below, or you can email me at nicolew@marssociety.org if you have any questions about the program. I will let Dr. Zubrin give his information and any updates about the program. After Dr. Zubrin speaks, I will be going over the rubric and syllabus for the contest. And on Thursday, we will meet again, and I will be doing an introduction to the planet Mars and other things about the beautiful planet that we will one day inhabit. So, Dr. Zubrin, you have the floor.
Okay, Nicole, just let me check with you. So are the rules pretty much the same as that of the previous contests?
Yes.
And how many teams do we have this year?
We are still getting signups as we speak. Right now, I believe we have 3 teams, hope to get 5 or 6.
All right, sounds great. Okay, so I'm an engineer, and when you go to engineering school in the university or graduate school, at a certain point along the way, they have what's called a design class. And in this class, what happens is the class works as a team, or perhaps is divided into several teams, to which each work together to design something. So let's say you're studying aerospace, and the assignment is to design a new kind of jet fighter. Okay, and you get certain requirements. It has to fly this high. It has to fly this far. It has to fly this fast. It has to be able to carry this much in the way of weapons. It can't cost more than a certain amount. Okay, now, so these are called requirements, and very often they are in conflict with each other. For instance, the more weapons you carry, the less weight you have available to use for engines. So if you try to carry too many weapons, you can't fly as fast as you could if you carried less. Either engines or weapons is mass that could go for fuel. And so they both take away from how far you can fly. And so there's no perfect design, because if you try to push one of its qualities too far, it will interfere with the rest. And so you have to decide, do I want a plane that's can fly really far, or do I want to have a plane that is very maneuverable, or do I want to have a plane that is very cheap? And so you typically, you might have different teams within the group, maybe one devoted to propulsion, one to aerodynamics, one to weapons, one to cost, one to structural strength. And these teams each try to come up with their best design, but then when they come together, they have to work out compromises to try to find the best overall design. Okay, so I, of course, went to engineering graduate school, and in fact, in both nuclear engineering and aerospace engineering. So I had experience of 2 such classes, and it occurred to me that this would be a great way to teach science in high school, in middle school, that even though you don't know as much science and engineering as university students do, nevertheless, the problem is still the same: to design something. And when you design something like this, it's very different from an ordinary kind of class where they say, here's what you need to know, and you're going to have a test on this on Thursday. And then, for you as students, it's very much, how much of this do we really need to know for the test, right? Okay, so knowledge in that case is a burden. But if you're designing something, knowledge is a tool or even a weapon. And so it's a much more interesting way to learn things. So we're going to have a design class here for you. And the class involves designing a human mission to Mars. Now, we're going to focus on the actual mission once you're on Mars, not the transportation technology, but what do you do when you get there? Okay, what do you bring to the surface? What is your exploration plan? So the and this, by the way, is something that, in my opinion, NASA does not pay enough attention to at all. They have at various times designed Mars missions without paying much attention to how much it will actually accomplish. So, for example, many of their Mars missions have involved very short surface stays. Now, but the purpose of the mission is exploration. And sure, you can limit the amount of food you have to bring to the surface if you only stay for 30 days, but you could stay for a year and a half and accomplish 20 times as much exploration. And given that the food is only a small fraction of the mass you're bringing to Mars, it's really a very bad trade to stay on the surface for just a few days, so what we call a flags and footprints mission. So, but it is true that the larger the crew and the longer they stay, the more provisions you will need to bring. And at a certain point, provisions start cutting into the scientific equipment that you can bring. Okay, so I believe that in this contest, we're giving you 30 tons of mass that you can bring to the surface. Okay, so we're not asking you to design the interplanetary spaceship. Your design problem begins at the landing. Okay, you've got a system that can deliver your crew, which could be up to 6 people, I believe, and up to 30 tons. And that 30 tons has got to include the surface habitat. It got to include all your surface vehicles. It has to include the life support system for the surface habitat. It's got to include space suits for everybody, maybe spare space suits. It's got to include, I forgot if I mentioned it, the surface vehicles, robots, aerial drones, if you're going to use them, like the Mars helicopter. Okay. Laboratory equipment, everything. Okay. And of course, provisions as well. So, and you can stay for up to a year and a half. All right. So you can have 6 people for a year and a half. That would give you the maximum number of person days on the surface. Or you could cut that a bit in either the number of people or the time in order to reduce the total amount of provisions or perhaps spacesuits that you bring in order to be able to bring more of other stuff. Now, furthermore, you're going to have to design the scientific program. In other words, you go to Mars, but Mars is a big place. Mars has got a surface area equal to all the continents put together of the Earth. Now, that's because 3/4 of the Earth is ocean. But if you just look at the land, Mars has got the same amount of land as the Earth has land. So it's a lot. And there's a lot of different kinds of places you could go to. And depending what your scientific research program is, you might choose different places. There's different kind of places you would go to, for instance, if you're searching for life on Mars, than if you're looking at the mineralogy of Mars, or if you're prospecting for resources for human exploration, settlement, or other sorts of things like that. So what you're going to need to do is, first of all, define the objectives of your mission. Okay, what is it? What's the most important thing you want to learn about Mars? And then you choose what's the best place to go in order to do that. And then you choose what kind of equipment you need to bring to best do that. And also, who should be in the crew? If you're bringing a crew of 4 people, say, what are the skills? Okay. In other words, are you bringing a pilot? Well, short answer is you might need a pilot to help do the landing, but he or she better have another skill or they're useless on the surface. Okay, so, but there are other people, biologists, if you're looking for life, chemists, geologist. You may need a mechanic. You may want two, because equipment failure is the major risk to the mission. If the equipment should fail, you're going to need at least one person who's really good at fixing things. Now, you might want to have people have more than one skill. Okay, I mentioned a biologist. Maybe that person could also be a doctor. Okay, you probably want a doctor in your crew, but if all he or she could do is be a doctor, they're not contributing directly to the exploration. So it'd be good if everyone on the crew has at least one skill that contributes directly to the exploration, but there are other skills that are needed in order to make the mission happen. Okay, so that's the idea here, to choose an objective for your mission. And in doing this, you need to learn a little bit about Mars and decide what is the most important thing to find out about Mars. Okay, is it to find out if Mars currently has life, or is it to find out if maybe Mars, not much chance of finding life on Mars, maybe you should be looking for fossils, or maybe it's resource exploration for settlement. Well, you need to figure out what it is you want to find out about Mars. And then you got to figure the best place and the best equipment and the best team. And then you want to kind of design the mission. Okay, how long are you going to stay on Mars? As I say, if you stay shorter, you can bring more equipment, but you have fewer person days on the surface to do the mission. So you can stay as short as 30 days or as long as a year and a half. Choose what is the best to accomplish the most. Okay, now, so the two main things you're going to be judged on is the scientific return of your mission and the competence of the engineering design. Okay, because, you know, if you introduce things that are science fiction, like, you know, I mean, well, just to make fun of it, magic carpets. Okay, there are no magic carpets, but if you had a magic carpet, you could travel all over Mars. It'd be great for exploration. But in other words, you don't want to be using phony technologies. Okay, now you can make an argument that it might be possible to build helicopters big enough for astronauts to travel in. We've had a tiny helicopter travel on Mars, maybe a fixed wing aircraft. Okay, because mobility is a very important thing if you want to do exploration. But what is the mobile system? And also, look, you've got a crew on Mars, and part of the mass you bring to the surface is their habitat. Now, the larger the crew, in general, the larger and more massive the habitat, but that takes away from scientific equipment. On the other hand, how far do you want to push that? You know, do you want to design a habitat that's big enough? Let's say you, once again, you have a crew of 5. That's big enough for a crew of 5, but if you make it too big and luxurious, that's going to impact directly on the scientific equipment. On the other hand, if you make it too small and cramped, that could impact crew morale. So you have to take into account human factors in providing an acceptable habitat for the crew to live in, especially if you plan to stay on the surface a longer period of time. The longer you stay, the more important that is. I mean, anybody, you know, can live inside of a car for a day or two, but you couldn't live inside of your car for 6 months. So there's a balance there that you're going to have to strike. So now, but you do want to have the best possible human environment. And if you use clever architectural ideas, there are ways that you can create the best possible habitat for its size. Okay. You know, the analogy I give is, you know, some people who live in small apartments have beds that fold up into couches. So the bed doesn't take up the whole room except when you're sleeping in it. Okay. So if you can think about that as an analogy of how can we create the most space for the people when they're awake, and then transform it into sleeping space, perhaps, to the extent possible. But that kind of thinking, or just clever architecture that creates a nice living environment without taking up too much of the mission's resources to do it. Okay, because we're not going to Mars to have the Club Med vacation. Okay, crew's going to be willing to rough it a bit, but you can't push that too far or you endanger the morale. So the two main factors you're going to be judged on is the scientific return that your mission gives, and it's the technical quality of the design. Okay, you got to do science, but it's got to work. Okay, that's the idea here. Now, here's the thing about this. We're doing this as a contest, right? So you're going to do a design and you'll present it to the judges. Nicole will tell you what the schedule is for that. But then you're going to have you're going to be able to look at the other team's designs at that point, not while you're doing your design, but after everybody presents their designs, you'll see what the other teams had to say. Then you're going to have a half hour, each team will have a half hour to attack all the other team's designs. In other words, you're going to have a chance to poke holes in their design, to show why their designs are inferior, either why they won't work or why the scientific return really isn't very much, or stuff like that. Okay, and especially, of course, the most dangerous criticisms are those that it won't work, because if it won't work, there's no science return. And it's very important when you do this, you don't do this in the form of personal attacks. Okay, and that's not just because it's not nice to engage in personal attacks. It's because personal attacks carry no weight in an engineering debate. Okay, so it's not about making fun of the other team or something. It's about showing why they are wrong. Okay, and then each team will have a half hour to debunk those attacks. So present, attack, and defend. Okay, so, and this is important because the other team might make an attack on your design, which is false. That is that they're wrong. They say something won't work, and in fact it will. And so they don't know what they're talking about. And so you can defend your design against them. And it's at that point, after each team has presented, attacked, and defended, then you'll be judged. So there's an element of here, it's kind of like debate. Okay, except it's not about debate style, it's about debate content. And you see, this is quite realistic because engineering, is competitive. And in fact, generally, it's not as nice as what I just described to you, because in general, your competitors will go behind your back and say things on why your design won't work without you even knowing that they're doing this. And so you're not there to refute them. In this contest, they'll have to say it in front of you. And so you'll have a chance to refute them, to defend your design. But that's the idea. And I think you'll learn a lot of engineering, and if you really get into it, you'll have a lot of fun.
Do you have time to take a couple questions, Dr.
I certainly do. I'd be happy to take questions.
Does anybody have any questions? Dr. Zubrin is the founder and president of the Mars Society, the world's largest Humans to Mars advocacy group. So you may not get this opportunity again. So
now, by the way, one good resource for all of you, I have a book called The Case for Mars.
It's I have it, I believe, listed on the rubric or the syllabus.
And you can get it from Amazon in either paperback or Kindle. And you may even be able to find it in your local public library, because a lot of libraries did get the book.
Hi, I'm sorry whether if this is a bit logistical, but I was wondering whether how the teams will work. considering that we're in different time zones?
So, oh, go, I'm sorry, Robert.
Well, you can explain this one.
Okay, so we are still signing people up. So some groups signed up as a team, so they can work that out. Once everybody's signed up, I'll do my best to get them to the closest time zone as possible. Some people may be in India, some people may be in China, California, Chile, wherever. So I do my best to get you to the closest time zone as possible. And that'll probably be hopefully by next Monday.
Okay. Thank
So
you.
you may be a time zone or two off from other people, but at least you won't be 8 time zones off.
Right.
Yeah. All right.
Anyone else?
Do you think Starliner will ever launch?
Starliner, oh, the Boeing thing.
Yeah.
It'll launch. I do think it will eventually launch.
Will it explode?
Starliner will not explode. It's now it could fail in various ways, but actually, okay, I may be old-fashioned on this, but I do think that the big aerospace contractors, they may be overpriced, but generally they do get their engineering right. And so I think so they're not as quick on the draw as SpaceX. They're not as friendly to failure as SpaceX is. SpaceX, of course, approaches things like, we'll build it, we'll launch it, it'll crash, we'll find out what went wrong, we'll try again. And of course, they're trying again with Starship this week after 3 failures, although each failure got further into the flight profile. But the main aerospace contractors like Boeing and Lockheed Martin don't like to fail at all. This makes them go slower and it makes them more costly. But they have a pretty good track record of mission success.
And as we all know, we learn more from our failures than our successes. And if
That's
we
true.
don't use a rocket or two along the way, we haven't learned.
Yeah.
But I can't tell you guys how important it is that Dr. Zubrin's here. If you have any questions about Mars or science, ask them now.
Yeah. As long as we're here, it doesn't have to be about the contest. I'll answer any questions you have.
What do you think the most important? Sorry, Megan. What do you think the most important milestone in that SpaceX will have to prove with Starship apart successful reentry of the ship?
Well, reentry and landing is going to be a big one. And then we'll see how it works as a system with maintenance, given that it has like 31 engines on the first stage and so forth. There's a lot there to maintain. So turning this, even after it succeeds as a flight vehicle, into something that's capable of rapid reuse. Falcon 9 has been a triumph, not only because it works, but because they can turn them around. I mean, they launched 100 of them last year, 2 a week, which is incredible. This thing's a lot bigger and it's a lot more complex. And also, of course, they are attempting to reuse the upper stage, which they don't on a Falcon 9. And the upper stage takes a lot more heating and beating than the lower stage does. Okay, so we'll see. It may turn out to be that the answer was right the first time, that you want to reuse the first stage, but not the second. It's a lot harder to reuse the upper stage, and the cost payoff is not as high by reusing the upper stage. You reuse the lower stage, the lower stage is much bigger than the upper stage. And the shuttle got this completely wrong by reusing the upper stage, but not the lower stage. That's why I've sometimes said the shuttle was built upside down. But we'll see. I mean, all these are questions, but if you want to know what my opinion is, I think they're going to make Starship work.
Mm-hmm.
It may take a bit longer than people hope, but it's going to work.
And
Can I,
do you think,
go ahead.
If there's no other questions, Leonardo, you're welcome
You're
to ask.
muted. Go ahead, Leonardo, go ahead.
do you think they're ever going to find a hard limit for the amount of times that they can fly the Falcon 9 first stage? Because they've flown it like 22 times already in a row. Do you think there's a point where it just becomes not feasible to keep flying it?
I don't know if there's a hard limit. There's probably a limit. You know, there's this Jimmy Stewart movie about an airliner that is not supposed to be flown more than 200 times or something. And they discover this is the 201st flight. It's going to crash. And of course, that's not how machines work. You have an expected lifetime for things. And beyond that, you're pushing statistical risk. It's not like if you rate it for 200 launches that it's going to fail on the 201st. It's just, you know, it's like a car gets too old at a certain point, failure becomes increasingly probable. But it's not like any car has a particular age limit beyond which it's going to fail.
I mean, what are the kinds of things that would make an old booster more likely to fail than a new booster?
Well, certainly it gets a lot of rattling around during launch and so forth. Some screws could come loose. Just a lot of, well, you know, like if you take a piece of metal and you flex it, and well, of course, you could take a piece of metal that you couldn't possibly break and you fold it this way, and then you fold it this way, and you fold it this way. You can actually break a piece of metal that way, right? And so that's an extreme case, but things can be weakened by excessive, you know, exposure to vibration and various stresses. And there's also heat stresses and so forth. You know, it's the engines themselves, you know, are the interior of a rocket engine is a temperature of like 3,000 centigrade. It only manages to live because it's being actively cooled. If one of the cooling channels should start getting clogged a little bit so that it doesn't, the coolant doesn't go through it enough, that could lead to ineffective cooling on even a little part of the engine chamber and cause it to go out. And for instance, well, the Falcons and the Starship, for that matter, both use hydrocarbon fuels. If you have, they're susceptible, maybe a little bit of the fuel breaks down and some carbon deposits are left behind, you know, that could eventually compromise the cooling of the engine. There's lots of things that could happen over time. My guess is we'll learn about them through an event. Yeah.
Can I ask you a question, Dr. Zubrin?
Sure.
I don't think I've ever asked you this before. What drew you to want to be a Humans to Mars advocate? What drew you to loving Mars and everything like that? Like, why Mars? What was the draw for you?
Well, it's different things to this question. I was 5 years old when Sputnik flew, the first satellite. And to the adults, this may have been a terrifying event because it meant the Soviets could hit us with missiles. You can circle the world, you can half circle them. But to me, as a child, and I was already reading science fiction, it was great. It meant that all these stories about space travel were going to be true. And I wanted to be part of that. So I learned all the science I could as I was growing up. And this was a very exciting time for people interested in space, because this was during the Apollo program, which happened at about the time I was the age of most of you. You know, I was 17 when we landed on the moon. And so a teenager during the period leading up to that. And we were going to go to Mars after that. And the general vision was then beyond. And unfortunately, while we did make it to the moon, Nixon, who was the president at that time, decided that that was all he wanted to do and shut down the whole fleet. It's like Columbus coming back from discovering America and Ferdinand and Isabella saying, we're not interested, get lost. So that's sort of what happened. And for a while, I accepted that and did other things. But then in the 80s, when I was about 30, I heard about some other people, my own generation, who were holding conferences called The Case for Mars, trying to put Mars back on the national agenda. And I went to one of these conferences, and I'm there, okay? This is what I wanted to be doing when I was 10, and I decided that I was going to do this. Look, what happened, the Apollo program was shut down when I was in college. And at that time, basically the world was saying to me, look, it's all fine to dream about being a space explorer when you're 10 years old or 12 years old. It's very cute. But now you've grown up and you just need to get a job and forget about that kind of stuff. And for a while I accepted that. But then, as I said, when I was about 30, and I was working a job, which was an okay job, but it wasn't what I wanted to do when I was 10. I said, no, this is not it. And that it's not true that there's a different species of people on the other side of the TV screen. Okay. That is, the real world got to me when I was in college and says, these people like astronauts, are the people, they're like movie stars. They're people who live on the other side of the TV screen. The people who live on our side of the TV screen could be policemen or teachers or accountants or lawyers or all sorts of things like that, but they can't be astronauts. Astronauts are like movie stars and presidents. They live on the other side of the TV screen, and you cannot be one of them. They live in this other reality, okay? But I decided, no, that's just not true. That all the people on the other side of the TV screen were once on my side of the TV screen, okay? And so I put my mind to it, and I became an aerospace engineer, actually an astronautical engineer. And it's something you can do. It's kind of a cliche like Disney, follow your dreams. But there's a lot of truth in it. There's a lot of truth in it. Everybody on the other side of the TV screen was once on your side of the TV screen. And if you want to become, it's hard to become an astronaut. That's true, because there's so few of them. But to be an aerospace engineer or a space scientist, someone who is part of this effort overall, and I would argue a more important part than astronauts, although we don't get this fame, but even so, we're the ones who make it happen. Okay. They're just riding around in the boxes that we build. But it's something you can do. If you want to do it, it's up to you.
Awesome. Very, very good. I was, it was the early 90s when I saw the Star Trek reunion show, and there were astronauts and scientists, and I didn't know, because I was in my early 20s. I was like, you can do that for a job? I thought the people on the TV only did that. So yeah, my story was similar, and I'm like, and I registered for all the science classes in college I could after that. And yeah, changed my life. It was wonderful. Peyton and Shreya are here. They're going to be student helpers, mentors. They're putting some stuff in the chat if you guys want to read that. And Robert, if you have anything else, or if anybody has any questions, going once, going twice, going 3 times, I'm gonna move on. Do you have another question, Leonardo?
Yeah.
Oh, go
Sorry.
ahead. No problem.
So I saw that Artemis 2 was delayed, largely because of heat shield problems with the Orion. Do you think those problems are systemic and they'll happen on every Artemis mission, or it's just something that only happened once during Artemis 1?
No, I think they'll get the problems with Orion down after a few flights, but there's another problem with Orion, which is really it's too big. It's too heavy for the SLS to get it into lunar orbit with enough propellant to come home, let alone with a lunar excursion module and enough propellant to come home. That is, in the Apollo program, there was the command module, which included the capsule, kind of like Orion, but it was much smaller than Orion. And the Saturn V was more powerful than the SLS. And we were able to design a mission. Well, first of all the pieces were designed as part of a whole. They were all designed to fit together. Whereas the problem with the Artemis program is you've got a bunch of different programs that are all being funded because of their own political strength, actually. That is the strength of the companies and their representatives and so forth. In other words, they're all standalone programs that do not fit together. In other words, it's not one design of which they are pieces. It's like somebody trying to create their dream house by buying things at garage sales and piling them up in the backyard and then saying, okay, now can we build a house out of this? Okay, instead of starting out with a design for a house and then choosing what you want to buy. That's the problem with the Artemis program. That's why, you've got things that just have nothing to do with each other, like the Gateway Station, Artemis, SLS, Starship, the National Lander. Okay, NASA had a program, for a human landing system. They awarded it to SpaceX. Okay, that made the other team, consisting of Blue Origin and Lockheed Martin, unhappy because they didn't get a contract. So they made a lot of noise, and finally, in order to shut them up, NASA said, okay, we'll give you a contract too. Fine, okay. But they didn't impose any requirement that they should fit together with the Starship that they were already funding. So Starship uses methane oxygen as propellant. The national team lander uses hydrogen oxygen as propellant. They could have told the national team, look, we'll give you your contract, but you have to use methane oxygen as your propellant because we want to have Starship be able to be a tanker that supports you. Okay, but instead, they just let them do their own thing. And I have to tell you that while it might have made a couple of engineers at the national team unhappy to be forced to change their design, management would have said, fine, just so long as we get the money, we'll design what you want, whatever the customer is always right. But NASA did not even have the degree of discipline to impose that on the national team. They just funded them. So this is why I, in my view, the Artemis is not a purpose-driven mission. It's a vendor-driven mission. Okay. And here, the reason why we're giving you this challenge of starting with what happens on Mars, okay, is that's a purpose-driven exercise. And then if you know what you need on Mars, it's after that you design the transportation system that can deliver it. Okay. So anyway, that's the point here, is we need purpose-driven programs in NASA. Okay. Apollo was purpose-driven, although this purpose wasn't scientific. It was strategic. It was to astonish the world with what free people could do. But that said, it wasn't done in order to give a lot of contractors money.
Mm.
Okay. It was done in order to send people to the moon and back. Okay. And if we're going to have a Mars mission, it shouldn't be an exercise in how many people can we give money to. It should be, how can we design the most effective mission?
Yep. Good, very good. Anybody else? Any other? I know Leonardo has 20 more questions.
Now, but here's Shreya has a question.
I wanted to ask for your take on Relativity Space's 3D printed rocket system.
Well, I think 3D printing is the future. The question of whether it's the immediate future or a little further out is a different question. They're pushing the envelope there on manufacturing. My own take, and I think they're moving a bit in this direction, to have some of the parts that are big and yet simple in shape not be 3D printed, because there's no need to 3D print them. Cylindrical tubes, why do you need to 3D print them? But things that are much more complex, 3D printing has a big advantage in printing things like turbine blades and all sorts of intricate things like that.
Nice, thank you. I also wanted to ask for your take on, do you think in like the near or the far future we would have a human mission to Europa? Considering the possibility there might be an ocean filled with life down there, do you think that will be something that will happen in the future?
Well, here's the problem with Europa, is that it's the second moon out from Jupiter of the big moons. The one that's close, the further closer you are to Jupiter, the stronger the radiation fields are. Jupiter has these very strong radiation fields, and they're impossibly strong at Io, which is the innermost moon. Okay, at Europa, they're kind of serious. They're not immediate killers, but I don't think you'd want to have people on Europa. But what you could do is have people go to the Jupiter system and station themselves further out, like at Ganymede or Callisto, and operate robots on Europa with essentially no time lag.
Sounds cool. Thank you.
Peyton?
So, I'm sure you're aware that pretty much the only other spacecraft that with the same amount of engines as the Starship was the Soviet N-1, which very famously blew up an entire launch pad. What do you think, besides computers, has been the major game changer that's made an N-1 magnitude launch vehicle possible in 2024?
Well, I do think that for all his aggressiveness, the quality control at SpaceX is considerably better than that in the Soviet program. Just culturally and in many other ways, things are done at SpaceX in a much more intelligent way than they were in the Soviet Union. So for anyone to do 31 engine booster is a challenge, but for the Soviets to do it, I think failure was baked in, unless they were willing to try it 10 times until they got it right, and apparently they weren't. If you look at the Soviet space program, they did pretty well with manned space flight. They did horrible with planetary missions. That is, essentially all of the Soviet missions to Mars failed, whereas almost all their human flights to orbit succeeded. And the reason why is human space flight, once you're up there, if you've got boosters that are proven, and now the issue is dealing with problems that occur in space, you've got people there to fix what goes wrong. Whereas on a Mars lander, you don't. And so this, by the way, is one illustration of why, in certain respects, human space flight is easier than robotic space flight. That is, if there's some little thing wrong, the people can fix it. Whereas if it happens on a unmanned mission, that's it. It's all she wrote. Look, the first Starship launch was pretty messy, actually. Not quite as messy as N1, but you know, at least 10% as messy. And they lost a bunch of engines. They sent debris flying for miles. They, in a way, they were kind of lucky that they didn't get shut down for that. But they're getting better. And the more they fly it, the lower the failure probability is going to be on each individual flight. But I wouldn't be surprised if somewhere along the way there is a complete Starship failure, because with 31 engines, it only takes one to blow up.
Anything else? Okay, I think we'll move on to the next portion. Robert, you are welcome to stay if you like. Otherwise,
there's something I got to take care of. But look,
Okay.
Good luck to everybody, and looking forward to seeing your designs and seeing your debate. Okay, which is
and
one part
seeing
of
them
this.
all hopefully in Seattle in August.
And see you in Seattle in August. All right.
Thank
So-
you, Robert.
Thank you.
Okay, Peyton and Shreya, I think that is all who have joined us today, are going to be student mentors for some teams. I haven't assigned those yet because the teams aren't made yet. So if you just would like to give us like a really quick couple of sentence introduction on who you are, you don't have to say where you live or anything like that, but how you like the experience and maybe one or two lessons you learn from the contest and what you may wanted to do differently. So let's start with Shreya.
All right. Hi, my name is Shreya. I live in the Eastern Time Zone, and I did the Mission to Mars program in 2022. It's first year. I really love to program and like the content and the structure. I love the lectures, and it also opened like many doors for me, like in terms of like pursuing other space opportunities. So like when I told my interviewer about what I did here, they were really impressed with it. And like, they love like the idea of like sort of like team guided learning and like doing your own research. And, a couple of things that I got from the competition and like, the program in general is that, my advice would be like to just think about everything. Like just think about everything. Like on Earth, we take a lot of things for granted, but on Mars, it's kind of like you have to think about every single thing. Because like, during a competition, I would like randomly be like, oh no, I forgot that part. And it's like some life-saving critical component. And another thing that you want to keep in a mission, especially, is I think Mr. Zubrin emphasized this before, but having redundancy. So having multiple backup systems for like your really critical systems. So like if your water system breaks down, make sure you have like a spare water supply or something else that you can use to like filter water, same with air or anything essential to them. And like keeping up backup tools and a lot of contingency plans for like what to do if something fails. So that way like your mission is more durable overall. But other than that, I'm really looking forward to seeing what this summer our teams will come up with.
Wonderful. Great information. Peyton?
Hey everybody, I'm Peyton. I was also in the inaugural class of 2022 for IMM. And I think the big takeaway that I got was just how much presentation skills go into being an engineer. I think it was at the last conference that Greg Autry said something about this, that basically you can't be a good creative these days if you can't present to investors, to, the people that are running your programs, to make sure you can keep your ideas alive. And that really is what me and Shreya and the entire rest of the program were doing, because we had to go through 3 rounds of presentations and sometimes got our entire mission roasted to bits. I remember what Shreya said about always checking your work, always making sure you have something incredibly important. My team forgot that we needed a drill to harvest ice water until I think it was like a day before our presentation. And I had to scramble through a bunch of papers to try to get something together. And it ended up being a weak point because we weren't able to find math statistics. But that's one of the things that you kind of have to use presentation skills either to cover up or to divert or to basically say, this is not a relevant point that you're arguing. So having those presentation skills, and you're going to develop them throughout the competition, is going to be incredibly useful in the future. And it's probably one of the biggest things I took away from this experience.
Great, wonderful. And Peyton, you were at the conference. Shreya, did you come to the conference? It seems like it was so long ago, I can't remember.
I was there for the 2022 one. I couldn't
Okay.
attend the 2023 one.
Okay, this year it's in Seattle, August 4th through 8th, I believe. So everyone's invited, of course. Any student mentors, judges, or student participants have free entry to the conference. Sorry. It's been a long day. All right, so just quickly, let me fix that real quick. I'm going to go over, if you guys need to pause to take a stretch break for a minute, you may do that. But I'm going to pull up the syllabus and rubric to go over. Now, we are doing things a little bit differently in order to preserve our relationship with all of our speakers. And instead of having the same speakers say the same speech every year, I've picked out some of what I think the most important talks are from the last 2 years. You do have access to every talk from every scientist over the last 2 years, but this is also good because so many people are in different time zones, and instead of having to log on, you can watch these at your leisure when you have time. Also, many schools are still in session, so we may have some really late entries to the competition. So don't be surprised if there are some changes to the teams. You do have access to these documents. I sent them out via email last week and maybe twice last week, I think. I am an emailer, so I will email lots of reminders for all the different things. We will meet again on Thursday. I will be giving a presentation about Mars, general information about Mars. And Peyton and Shreya, if you would like to give out your email, it's not mandatory, but if you would like, you can put that in the chat in case anybody needs some advice. Now, as mentors, we are not allowed to tell people what to do or say, you made a really big mistake. They have to figure that out. You can say things like, you may want to think about your water supply, but don't tell them what to do with their water supply, something like that. Okay, so International Mission to Mars Design Competition rubric. Your challenge is to design a human mission to Mars. The purpose is to accomplish as much scientific exploration as possible. You will be designing a Mars surface mission. So remember, you don't have to build any rockets. You don't have to take the time to get there. You are getting landed on Mars as a team. Once you're there, what do you need to survive? You're going to keep in mind science, engineering, and human operational challenges. That could be psychological, that could be, physical, engineering, building like your habitat, science, like, am I going to find a microbe? And then what do I do? How do I keep my crew safe if we do find microbes there? So your team should divide itself into 3 groups listed here: science, engineering, and human operations. And I'm going to delete cost because we took that out of the competition. because people were making up numbers. Um, so just human operations, science and engineering. So you have up to 1.5 years, up to a year and a half on Mars. You do not have to stay for a year and a half. You can have a year and a half. Now, you do need to have proper launch windows. Don't make up dates. Okay, so you have to find out when real launch windows are. We'll talk more about that on Thursday. So you have to have actual launch windows. Also, use all metrics. Don't mix miles and kilometers and centimeters and inches in your report. Use all metrics. Science around the world uses metrics. The US is a little behind in that. You may split the weight in two for separate launches. And then here's a list of what types of things you should include in the weight. You can have up to 6 Marsonauts or Martian astronauts. And then you need to think about who should be in the crew. What are their skills? What is their compatibility? Is there a commander, etc.? I'm not going to read every word of this to you. Water. Of course, we need a lot of water. You're not going to land on Mars and there's not going to be a well right there ready for you to drink from on the initial mission. You have to figure out how to get water, how to get clean water, how to get enough water. Food. What kind of food is your crew going to eat? Where will it come from? How much is it going to weigh? Because you have to consider that in the weight of your mission. You have to choose an appropriate landing site. So a big part of this competition is teamwork. If you've ever watched sports and seen teams that are very successful over long periods of time, they very likely have very good team building skills and teamwork. Teams that have I'm the star type of things, they may win a championship, but they're not going to win very many. So you want to work together as a team to decide these things and not argue about little things. Work together, compromise. Power, what kind of power supply are you going to have? There's no electricity on Mars. So you have to figure out how are you going to turn the lights on? How are you going to warm up your habitat? How are you going to clean the water that you get from wherever you get it? Are you going to bring your food or grow your food? And how would you go about that? And here again, I believe Peyton mentioned this earlier, have redundancy in, was that you, Peyton? Or Shreya? One of you mentioned the
That was Shreya.
Okay,
Yeah.
sorry. Redundancy is very, very important. NASA and space organizations talk about that a lot. Always having a backup to the backup. You don't want to run out of water because you will not survive more than 3 or 4 days without it. So that's like number one for redundancy. You want to make sure your habitat's pressurized. So if your pressurized system goes out, you need to have a backup plan for that. The maximum diameter for your HAB is 8 meters. You can have a rigid or inflatable structure. You need life support. I'm going to take the cost out. Disputes. What if you have a dispute on your mission to Mars? What if you have a dispute with your team here on Earth? Here are just a few ideas for exploration: geology, climatology, paleontology. Like, is there past life? Astrobiology, is there present life? Resources for future use. So if you get to Mars and you just happen to dig a well and there's a huge water supply, you may want to let the next crew know, because if one crew gets there, inevitably there will be another one later. How do you reach the best possible overall design? This will generally include some type of compromise with your team, because you have to optimize the various features of your design. Dr. Zubrin talked a lot about that. So your design report is due at the end of the 4th week, 6 p.m. Pacific time, July 7th. This will go a lot faster than you think it will. So you have to really be a self-starter, because we have 2 meetings this week and 2 meetings next week. And everything else you're doing on your own. You will be able to contact me and the other mentors that we will assign at any time, but you will have to be able to get to work and not have to be prompted. I'm not going to email you every day and say, did you do the part of your project yet? I'm not your teacher at school. This is a very much, you're going to get up and do it every day and finish the project and be there for your team. So it'll be a 25-page limit for the paper that you're going to write, 12 font standard margins, 3 sections. They don't have to be even, so they don't have to be like, 7.5 pages each or 8 pages each. They can be 5 pages, 8 pages, and 10 pages or whatever. They can be, because every one of them is going to be a little different. Each team member is responsible for their own portion of the report. You may use publicly available images or draw your own. Reference information is not included in the 25 pages, so please reference all of the sources. So every contest, and I know Shreya and Peyton are still waiting for the book to be published. Dr. Zubrin has it. He's sending it to his publisher for last edit. When that will be, I'm not sure. But if you guys want your reports published in a book, you must follow this format, because I spent probably 4 or 5 months between my other job and this job formatting everybody's papers because they were all very different. So follow this format when you submit your final paper. That way, when I submit it to be published, it goes much smoother and much more quickly for publication. Monday, July 8th will be when you present your design. Having a slideshow is very, very important. So make sure you put it in a slideshow. You can just use what's in your paper and put it in your slideshow. You don't have to make a whole new report. Just kind of make a summary of what's in your report into a slideshow. The second round is where you guys kind of critique each other's flaws, what you think is incorrect in the project. The third round is where you defend the critiques from the second round, when you have your closing argument and say, no, my design was right. Or you say, no, you guys were right. I made a mistake. I need to fix that. You will be given feedback depending on the time available to the judges, but you should have a final answer of who won by the first week of August. Now, that being said, I am traveling for an in-person design competition in the middle of July. So like right after you guys are done, I'll be gone for like 10 days teaching this same contest in LA. So if you don't get an answer immediately, that's just because I'm traveling for the same competition for another group of students. So don't get mad if it's maybe August 7th or 8th or something, but I should be done before then, because we'll be in Seattle for the conference by then. So you should have an answer before then. All right, here's the judging: 40 points for science, 40 engineering, 20 for human factors. Dr. Zubrin is one of the judges. I'm one of the judges. And then we have a couple of other judges who will be reading the reports. So you want it to look as professional as possible, and you want it to be cited very clearly. Make sure you have all your resources in your paper. The syllabus with links. So I'll show you the syllabus in a minute. All of last year's and the year before's lectures are on YouTube. Here's Dr. Zubrin's Mars Direct. I would watch this first. It's all linked here. Just click it and it'll open. This is marspedia.org. All of these links here. There's tons of good information there. If you go to Wikipedia, I am not recommending using it as a source because I've actually found mistakes about Mars on that website, but there are resources at the bottom of every page. I would go directly to the original sources and make sure they're legitimate sources if you're going to use that. And then here's a FAQ So I'm not going to read all of these, but here's some commonly asked questions. If you have any other questions, email me. And go to the syllabus. I think there's some stuff in the chat here. Emails. Are we allowed to use KSP as, what's KSP? I don't know what that is.
It's a video game. It's short for Kerbal Space Program.
Oh. I don't know.
Basically, it's pretty realistic. Like I'd say, I've done an orbital mechanics course before where I basically memorized from the game what the Delta V looks like to go to the moon.
Okay.
And that's how I fact
Yeah.
check my actual calculations. But it's not good for, down to the kilogram tuning your mission. So I wouldn't recommend it. If you download a lot of mods, you can probably use that for visuals if you build your design and land it on Mars and take pictures of it. But I wouldn't recommend that for actual calculations.
Oh, good, good. I did not know any of that. And Shreya, let them come up with that. And then Peyton's right about the extra document. Yes, it's worth it because I had to go back to a couple of teams this year to make them redo the whole thing because it wasn't ready for publication. You will not have access to past papers. No, but you will have access to all of the presentations are on YouTube, on the Mars Society's YouTube channel. All of the presentations from everyone here who participated before are all there on YouTube. All right, so today we met. Now, every time we meet, there's a new link. So Thursday, here's the new link. I'll send it again before we meet. But here is the list. I would start here with Dr. Zubrin's Mars Direct. Here is last year's, all of the blue are the links to other videos. This is the introduction from last year. It's basically pretty much the same as what you're hearing now. So that's not 100%, mandatory, but Mars Direct is Chris McKay, who is a wonderful NASA scientist. He's been a NASA scientist for decades. He was the first NASA scientist to help me with my astrobiology projects when I was in undergraduate school. Detecting life on Mars is his greatest love. So here's his video and bio. And then here are all of the other, I think there might be 5 or 6 videos to watch prior to our meeting on Thursday. And then a link to the playlist for all of last year's, the past 2 years recordings. So there are more than what is on this list, but these are the main ones that have enough information to get you started. And then Thursday, again, I will send you the Zoom link again for Thursday's meeting because it's a different link. I will also be presenting general information about Mars. If the student mentors don't want to be here, you don't have to be here for that. It's basically the same as what I presented last year. But then another list of these videos from presenters from last year and the year before, all very important, wonderful scientists. And then we'll meet again next Monday with another new video link. And then we'll do a lot of Q&A, see how you're doing. Hopefully we'll have all the teams set by then. And then another list of videos. And then next Thursday on the 13th, we'll meet for the last time before you go off to do your projects, and another new link for Zoom, and just the wrap up and any more questions you have. There was something else I was going to tell you. And then more information about your design activities with everything, how to write up your paper and how to follow the first heading, second heading, et cetera, same as on the rubric. And then round 1 is July 8th, presentations. Round 2 is July 10th. Round 3 is July 12th. And then the announcement of results theoretically will be by July 29th. You guys, oh, I know what I was going to tell you. I have contacted the scientists from most of these videos. And if you have questions for the scientists, make a list, tell me the name of the scientist and what your questions are, because they've agreed to answer them by email. So you send me their questions with their name. I will email them and get their answers. Some of the questions are questions I can answer, but some of them may be more detailed that I can send to them to answer. So you will have access to ask these scientists questions through me via email. And that is the syllabus and rubric. Does anybody have any questions?
I wanted to ask if we're still using Discord to communicate with teams.
So that's up to the team.
All right.
So students who are participating this year, do you have any opinions, yay or nay, about using Discord? Is anybody here already on a team that they signed up with? Are you all individual signups or team signups? Nobody's saying anything.
I can
I didn't hear you. You individual, Leonardo?
yeah, individual.
Okay. Nobody else? And Anaya, is that how I say your name? Oh, you're muted.
Individuals.
Individual, okay.
Andrea?
We are in a team. I'm in a team with a couple more people, actually more than a couple.
Okay.
Oh.
Do you have more than 5?
I'm not sure. Let me actually, yes. I think we have let's see. We have 6 people.
Okay, 6 is fine.
Okay.
6 is the max.
Okay.
Okay. Faduli, Adriana, David, Zevri, anybody, are you guys individual or team?
I'm along with a 6 people team.
With Andrea?
Yes,
Okay. Okay, I guess everybody else is
I have a team of 4.
You have what?
A team of 4 people.
Okay, perfect. And okay, so if you have any questions between now and then, you can email me. My email address is on the syllabus, and I've emailed you all already. I did get a couple of bounce backs from emails that were used to sign up. So if you have contact with your teammates, please check with them to see if they got my emails, because there were 2 or 3 students whose emails did not go through when I sent them. And so what about the Discord? Does anybody not want to use Discord?
No, I think we all have Discord. For example, in my team, everyone uses Discord and it's fine.
Okay, perfect. So Peyton has linked the Mars Society's Discord server in the chat. So you will make a subset, a subgroup. I don't know how you call it, Peyton.
We can either make another server, or if you want, we can get the server admins to put you guys in a category in the Mars Society that will go away after the competition. I do recommend just having a server to yourself.
Yeah, okay. Yeah, okay. So you guys all discuss amongst yourselves offline what you're gonna do, and I think you're right. It'll be easier and quicker if you set up your own Discord server. And when you get assigned a mentor, you'll share that information with them so they can answer any questions there. Anybody have any other questions? So for your teammates who aren't here, this will go up on YouTube on the Mars Society channel at some point within the next couple of days. And I will share that link with you. And thank you guys. Hopefully we'll get a lot more signups once all the schools get out, because a bunch of schools are still in service. Thank you. Email me any questions. And thank you to my student mentors from past years. I really appreciate your help. And I will see you all on Thursday. Bye.
Bye,
Bye.
y'all.
Bye.
Have a nice
Bye.
day.